Today we're going to talk about inscribed angles, and we've got some angles that aren't inscribed, so I threw that little term in there in the title, but mostly it's about inscribed angles. So what is an inscribed angle? Well, let's look at a circle here. An inscribed angle is an angle whose vertex is on the circle and the sides of the angle contain chords of the circle. So if this is A, B, C, angle ABC is an inscribed angle. Sides are chords of the circle, vertex is on the circle. Inscribed angle. Okay, and this arc here, let me highlight this. This arc here, arc AC, is an intercepted arc. And what is an intercepted arc? It's an arc with endpoints on the sides of an inscribed angle. An arc with endpoints on the sides of an inscribed angle and its other points in the interior of an angle. So this arc, the other points are in here in the interior of this inscribed angle. Okay, so we got the inscribed angle, we got the arc it intercepts, and now we got the theorem. We got the theorem that tells us the measure of an inscribed angle is half the measure of its intercepted arc. So let's see how that's going to look when we do a couple of problems here. Okay, in our example, it says what are the values of A and B? Okay, A is our arc here, so we know that the measure of angle PQT is 1/2 the measure of arc PT, and we know what the measure of PQT is, right? It's 60. 60 degrees is 1/2 measure of arc PT. So that means A, which is the measure of arc PT, is going to be 120. And the degrees is already there, so we don't have to add that. Okay, how about B? Well, let's see. B, since we know A is 120, we know that arc PT and arc TS together are 150, and then we know that B is going to be 1/2 of 150, so B is going to be 75, and the measure is degrees. Okay, why don't you pause here and do this example, and then we'll roll on. Okay, what'd you get? For the measure of angle A, got 95 degrees, 1/2 of the intercepted arc, which is 100 plus 90. Measure of angle B, 77 degrees, using the same method. Measure of angle C, 85 degrees, and the measure of angle D is 103 degrees. If you have any problem with those, let me know in class and we'll talk about it. And I want to ask you, look at angle A and angle C, right? Angle A and angle C are opposite angles. What we can say here is this is a quadrilateral. ABCD is a quadrilateral inscribed in a circle. And look at the opposite angles. Angle A, 95 degrees. Angle C, 85 degrees. Okay. Angle B here is 77 degrees. Angle D is 103 degrees. What do you notice about those opposite angles? I'll tell you what you notice. You notice the corollary 3 of this next, well, this is a corollary to the original theorem that we learned in this lesson, and it tells us that the opposite angles of a quadrilateral inscribed in a circle are supplementary, and that's what we saw in the previous problem there, right? Those opposite angles are supplementary. 95 and 85 is 180, 77 and 103 is 180. So, yep, that's what we got. Let's see what these other two corollaries say. Two inscribed angles that intercept the same arc are congruent. Well, that makes sense. Look at angle A and angle B here. They're both intercepting this arc, so it makes sense that those two angles would be congruent. And corollary 2 tells us that an angle inscribed in a semicircle is a right angle. So this angle C here, it's inscribed in this semicircle, right? both of the endpoints of the sides of this angle are on the diameter of the circle. So always going to be a right angle if it's inscribed in a semicircle. So let's see what problems we got left. Okay, let's do these 3 problems. What is the measure of each numbered angle? Well, angle 1 here, I can see, is inscribed in a semicircle. So the measure of angle 1 is 90 degrees. That's all that's asked of us. If I ask you what the measure of this angle is here that I've highlighted in green, what would you tell me? Well, let's see, the intercepted arc is 110, right? So I believe that angle would measure 55. All right, let's look at problem B. Angle 2 here, angle 2 intercepts this arc right here, right? Which also happens to be the same arc that this angle intercepts, right? So the measure of angle 2 is going to be 38 degrees. And of course we know the measure of that arc would be 76 degrees. Okay, why don't you pause here, do this next one, and come back and check. All right, I can see that angles 1 and 3 are both inscribed in a semicircle, so they're each going to measure 90 degrees. And then if I look at angle 4, well, I think I did angle 2 first actually. Angle 2 intercepts this entire arc here, that's 100 plus 120. So the measure of angle 2 is half of the sum of those. Half of 220 is 110. And then again by the corollary, I know that angle 4 is going to be supplementary to 2, so it's going to be 70 degrees. All right, we got another theorem here, and it says the measure of an angle formed by a tangent and a chord. So let's look at this here. Here's the tangent, here's the chord. It's half the measure of the intercepted arc. So again, here's the tangent right here. Here's the chord. Uh-oh. All right, so let's do a problem using that. Example. SR is tangent to the circle at Q. Okay, there's our point of tangency. If the measure of arc PMQ is 212, what is the measure of angle PQR? So I'm looking for this angle right here. Okay, I know the measure of that angle. Measure of angle PQR is going to be half the measure of arc PQ, right? Half the measure of the intercepted arc. Measure of an angle formed by a tangent, half the measure of the intercepted arc. Okay, well, we got 2 ways we could do this. We could figure out what the measure of this arc is and then half it, or we could figure out what the measure of this angle right here is, and then we could subtract that from 180. So I think what I'm going to do is I'm going to say the measure of arc PQ is 360 minus 212, right? 360 minus 212, and that's going to be 148. And so I know the measure of angle PQR is half of 148, which is going to be 74 degrees. All right, why don't you do the next one? Come back and, oh, let's see what we got. Oh, all we have left is some practice problems. So how about you give these a try? There's nothing new. It's just these new theorems that we've learned today. So you give these a try, come back and check them. And if you need me to help you in class tomorrow, please let me know. All right, I think this is where we left off. So we've got KJ tangent to the circle at J. What are the values of X and Y? So I started with Y. And what I know is this, that this angle right here is a right angle, right? Because it's inscribed in a semicircle. And so using the triangle angle sum theorem, I just, well, and I actually also know that 35 plus y, 35 degrees and y are complementary because the other two angles in a right triangle are complementary. So that's why I know that y is 55. And that also tells me that this arc right here, QJ, is twice 55, which is 110 degrees. And so that tells me that this little arc right in here is 180 minus that, which is 70 degrees. And therefore that little angle there at J is 1/2 of 70, which is 35. Okay, next one. Well, let's see what we have. I've got this intercepted arc here of 108 degrees. So I know that A has to be half that. So that's where the 54 comes from. This angle that has B intercepts a 60-degree arc. Therefore, I know that angle has to be 30 degrees. And I know that C is congruent to this angle, right? Because they're vertical angles. So I use the triangle angle sum theorem to prove to myself that, well, I don't know where that 9 came from. This is 96. C is 96. Okay. Next one. What do we got? We've actually got B and C both intercepting the same arc, which happens to be a semicircle. So B and C are 90 degrees, they're right angles. And then we've got a 25-degree angle intercepting this arc here at A. So I know A is going to be twice that, which is 50. Okay, got a lot going on here. Let's see what we know. I got a semicircle here on this side. Semicircle. So that's why I know this little arc down here at E is 60 degrees. It's 180 minus 120. So that's where the 60 comes from. Okay, that angle that's labeled as A intercepts that 60-degree arc. So I know that A has to be 1/2 of 60, which is 30. All right, I know A plus B is a right angle. So that means B has to be 60 degrees. And let's see, if this little arc down here is 56, then I know the rest of that semicircle is 180 minus 56, which is labeled D, and therefore that's 124. And I know then that C has to be half of that intercepted arc, and therefore that angle there is 62 degrees. Okay, next one. All right, we had to draw ourselves a little right triangle in here, so that's what I did. And I know that that's also a radius of that circle. And I have to remember from the previous lesson that if I extended this, it would be a diameter. It's perpendicular to this chord. Therefore, I know that it's going to bisect this chord, which is going to make that side of the right triangle 15. And then I just used the Pythagorean theorem. But first I divided both of my sides by 3. So I made that one a 3, that one a 5. Pythagorean theorem gives me that x. When I do this, x is the square root of 34. But I have to remember that I divided by 3. So then I got to multiply that, put that 3 back in there. So that radius of that circle is 3 times the square root of 34. And finally, kind of got the same situation here. This entire arc is labeled X, and that's what we're trying to find. So what we're going to do is find this side of this right triangle, and then we'll multiply it by 2. I used the Pythagorean theorem to do that. I could have divided both of those sides by 5. That would have made it a smaller number. I don't know if it would have made it any easier, though. But in the end, I ended up with that side of the triangle A being 5 times the square root of 3, and then when I double that to get the length of that chord, I get 10 times the square root of 3. All right, guys, that's your lesson on inscribed angles. We'll see you next time.